Actually, instead of reading from a paper, I will read from a slide. The biographies of our two speakers. First, Dr. Hannes Jung. Hannes Jung was born in 1955 in Germany. He studied physics in the University of Freiburg, where as a student he became a member of the European Union collaboration experiments at CERN. Then he did his PhD in the University of Hamburg, working for the cello experiment, you may say. Cello experiment at the Petra Electron Positron Accelerator at DESY. As a postdoc, then he worked in the H1 experiment at the Hira ring, also at DESY. And then he did 5 years as a research associate in Aachen, 2 years as a visiting scientist in France, and 8 years of as a researcher in Sweden, to finally then return to Hamburg in 2004 as a senior researcher, DESY, and as a docent in particle physics in the University of Hamburg. He is a member of the CMS collaboration, where many of our physicists in our institutes take part as well, in the LHC at CERN since 2007, and he had leadership roles in various experimental and phenomenology working groups. In 2021, he became emeritus, and he was also a guest professor at the University of Antwerp, Belgium, between 2009 and 2017. And his main focuses are phenomenology in QCD and interpretation of measurements. He's author of several Monte Carlo generators. And finally, what interested me more, he is the founder of the Science4Peace Forum in 2022, which is what he will present to us today. Our second speaker is a well-renowned physicist, Professor John Ellis. He was born in 1946 in the UK. He studied physics in the King's College in Cambridge. He earned his PhD in theoretical physics in 1971 from Cambridge University, having spent 1 year as a visiting scientist at CERN. After 1 year of postdoc at SLAG in Caltech, he went back to CERN in 1973, first as a research fellow, and from the next year, from 1974, as a staff member, where he remained until 2011 when he retired. At CERN, he was a theory division leader for 6 years, and he currently holds the Clerk Maxwell Professorship of Theoretical Physics at King's College in London. His research interests focus on phenomenological aspects of elementary particle physics and its connections with astrophysics, cosmology, and quantum gravity. Most of his work relates directly to interpreting results of searches for new particles. The gluon, for example, was discovered at DESY in 1979 using a research strategy that he proposed. And he was one of the first to study how the Higgs boson could be produced and discovered. He is currently very active in efforts to understand the Higgs particle discovered at CERN in 2012, as well as its implications for possible new physics, such as dark matter and supersymmetry. Professor Ellis was awarded the Maxwell Medal in 1982 and the Paul Dirac Prize in 2005 by the Institute of Physics. He was elected Fellow of the Royal Society of London in 1985 and of the Institute of Physics in 1991. And he's an honorary fellow of the King's College, Cambridge, and the King's College, London. Has been awarded several honorary doctorates. Apart from his outstanding career, he's also known for his relentless efforts to promote global collaboration in particle physics. And this is the reason why he was invited to this colloquium. He is, of course, a member of the Science4Peace Forum. So we will start with the presentation first by Hannes, and then by Jung.
Oh, thanks very much for this very nice introduction and invitation. I'm really very pleased to be here and to talk to you about the Science4Peace Forum. And I'm also very pleased that so many young people are here, because it's a topic which affects everybody, and especially also young people. In the following, I will tell you a bit about the Science4Peace Forum and also my motivation to engage in the Science4Peace activities, and also will tell you some about our activities, which we recently started, and most of all, why I'm also thinking that all this is very important. So I have prepared slides and a text formulated, because it's a bit different topic than talking about diagrams and plots and physics. So I needed to have the proper formulation thought through before. Now, the Science4Peace Forum was created after the war of the Russian Federation against Ukraine started in February 2022, and as a reaction of some of the science institutes imposed immediately after it. I think it was one of the quickest decisions of science institutions in Germany, and perhaps also in other areas, to declare just after 2 days after the war started very significant sanctions against Russian scientists. The directorate at DESY immediately imposed even stronger measures and excluded all Russian scientists from DESY, removed their access to emails and computing, and banned all common publications with Russian scientists. At DESY and at CERN, scientists and employees immediately stood up and wrote a letter to the directorate warning very strongly of consequences of such reactions. In this letter, we said, we sincerely ask, in solidarity with our Ukrainian colleagues and friends, and with our Russian colleagues and friends who courageously exposing their dissent to the war, are taking great risk of their person, family, and careers, we ask to do everything to stop the escalation spiral and to return to diplomacy and negotiations, and to withdraw sanctions from fundamental research and scientific collaborations. In order to have a forum to talk about these measures and the sanctions, and to be able to discuss and exchange the hopes and fears with all our colleagues, and to support the Science4Peace idea, which was actually the founding principle of CERN, we have founded the Science4Peace Forum in March 2022. Let me say a few words about the history of DESY and CERN, and about my own experience in these institutes. CERN went 70 years old in September, and DESY went 65 years old in December 2024, last year. I've been working at CERN and at DESY since the beginning of my scientific career, And now I'm emeritus at DESY, which certainly brings quite some advantages. For example, without worrying about the consequences, being able to say what many others think but do not dare. I'm still active in research and my heart beats still for particle physics. The largest collider at DESY was the Hera ring, colliding electrons and protons at energies not available before, and still are the highest energies of this kind of collider. One of the main okay. So one of the main topics of the Hera ring was strong interactions, which is also one of my favorite topics. It is about the big questions about how the universe is built, how protons and neutrons are built, the components of atoms and molecules. It's about quarks and gluons, which are the glue of the quarks. And to explore all this, we need highest energies, and for this we need particle accelerators. My first contact with CERN I had during my diploma thesis in Freiburg in the period from 1983 to 1984, quite a long time ago, where we had regular stays at CERN. There I met colleagues from Poland, from the Soviet Union, and from the GDR. It was really incredible. I could talk to people, drink coffee and a glass of wine, talk to people with whom I never had contact before and was able to talk to them. And I could ask and discuss with them. This was the time of the so-called Krefelder Appell in Germany. Many people, including also many scientists, were opposing the stationing of long-range missiles, the Pershing II. It was the time when Sting, the composer and musician, sang in his song Russians in 1985, and here's a picture of it. And he sang, "There's no such thing as a winnable war. It's a lie we don't believe anymore. We share the same biology regardless of ideology. Believe me when I say to you, I hope the Russians love their children too." And he re-recorded this song again in 2022. I think it could not be more relevant. It was the time of the SDI project of the US President Ronald Reagan, the Strategic Defense Initiative, to station weapons in space to protect against possible attacks, but also to carry out attacks, of course, only for defense. Interestingly, laser weapons and even free electron lasers were discussed at that time, which are now operating at several accelerators. There was a broad movement against this, and many physicists have spoken out explicitly against participating in these plans for space armament. Coming back to CERN, CERN, the International Center for Particle Physics in Geneva, was built from the experience of the Second World War by scientists who were at war just a few years before. It was founded in 1954, and with it, the Science4Peace idea was born. John Ellis will talk about that later in much more detail. Basic research is universal. The question on the origin of the universe is independent of national and political interest. This provided an opportunity to build trust and mutual respect in scientific cooperation, and thus also gave the opportunity for exchange. The Constitution of CERN says in Article 2, the organization shall have no concern to work for military requirements. This is a very important statement, very important declaration, which I will come back to a bit later. DESY was founded just 5 years later than CERN in 1959 as a national research center. The constitution of DESY did not and still does not contain any focus on peaceful or civilian research. But I think this was not necessary at that time. since Germany had no army until 1955. It joined only NATO in the same year. The German nuclear program started in 1955 to develop civil and peaceful use of nuclear energy. Anything else was not allowed by the Allied States. And I hope this was the reason why nothing about military research was mentioned in DESY's constitution. As you remember, it was a time where there were still two German states existing, belonging to different military and political blocs. In a report from DESY on the history of the institute in Zeuden, or close to Berlin, it is said that this institute had in the GDR, in the German Democratic Republic, belonging to the Eastern Bloc, had already cooperation with DESY in the Western Bloc in the years of 1963 to 1967. This was the hot time of the Cold War. The same institute in Zeuden had also cooperations with Berkeley in the US already back in the years from 1955 to 1960. Later, the institute in Zeuden in the GDR joined the H1 experiment at the Hero Collider at DESY, still during the Cold War. And scientists from the GDR were visiting Hamburg. And I still remember a report of a colleague from Zeuden in a meeting of the Hamburg Science4Peace group about the worrying situation in the GDR, years before the fall of the Berlin Wall. This was a very unbelievable experience to hear directly about political situation there and to be able to discuss. And I think this was only possible since we had collaborations with institutes and people from the Eastern Bloc at DESY already then. And this was only possible because we performed fundamental research. Cooperation with institutes of the Soviet Union in experiments at DESY started even much earlier. They go back to 1978. A new detector for E+ E- experiments at the storage ring Doris was proposed, the Argus detector. This detector is still as an exhibition in the entrance hall of DESY in Hamburg, and here you see a picture. Since there were increasing number of cooperations with institutes of the then Soviet Union and many other countries in the East. In a public presentation in 1966 at DESY, the cooperation with Russian institutes was celebrated. Cooperation with the Lebedev Institute goes back to 1983. The institute became official member of the H1 collaboration in 1986. This was all before the change and the breakdown of the Soviet Union and the Eastern Bloc. In 1988, a huge amount of iron modules produced at plants near Leningrad, now St. Petersburg, were transported to Hamburg for the iron structure of the H1 experiment. And this was also the time where the new missiles were to be stationed in Germany and where the big peace movements in Germany started. During a time of political confrontation, there was this good and very important scientific exchange. Unbelievable. A very fascinating and wonderful example, and I can't resist to show that to you, although I guess John will also show it because it's such a wonderful example, is on successful scientific cooperation in the sense of swords for block shares is the construction of a part of the detector of the CMS experiment at the LHC at CERN. Very high quality brass was needed, and the Russian colleagues remembered that their Navy had used high quality brass for vessels in the 1940s, and millions of it were still stored in military stocks. The approval for use of this material came quickly from the Russian Naval Command, and these vessels were loaded, then melted in Belarus and transported to CERN and installed as absorber material in the CMS detector at CERN. In the detector book of the CERN collaboration, it is written, on this citation, this project was part of an international agreement to convert Russian military industry into peaceful technology. The recycling of stocks of ship artillery into materials for fundamental research was also symbolic. Instead of being used to destroy, the weapons could actively benefit humankind through their contribution to enhance knowledge and technology. A beautiful example of international collaboration and mutual trust through scientific collaboration. What can one imagine as a better use of Navy vessels? All this has fundamentally changed with the beginning of the war against Ukraine. In Germany, all cooperations with Russia were terminated. DESY took a particularly strong position. Russian scientists had to leave the institute. Even scientists who had lived and worked in Germany for more than 20 years were no longer allowed to use their email address and computer access at DESY. These sanctions are still in place today. But not only this, even common publications with scientists from Russia were no longer allowed. The work I was participating could not be published with my name on. DESY did not allow to mention the Russian affiliations. I think it was a very discriminatory action. Even more, DESY did not allow participation in conferences where scientists from Russia presented talks. Conference organizers had a very hard time to run conferences, and it was and still is a nightmare. But now the DIS conference on deep inelastic scattering, is organized in South Africa, and there Russian scientists can participate again. Interestingly, in contrast to DESY, the University of Hamburg, which is very close by, put future cooperations with Russia on hold, but did not explicitly ban any publication with Russian scientists. But not only DESY, also CERN launched sanctions against Russian scientists. There was and is great protest against these measures. The Science4Peace Forum has organized events, collected signatures, and published 2 articles against the exclusion of scientists. At CERN, the CERN Council decided to end the cooperation with Russian and Belarusian institutes by the end of 2024, and scientists had to leave CERN and the experiments. I guess John will say much more about this in his talk. The consequences of this decision are not yet foreseeable. An international institute, which has UN observer status, which is founded by UNESCO, expels scientists without any endorsement from the UN Security Council or any other international body, just because of political pressure of some countries. The consequences of this are not yet foreseeable. Obviously, the Russian scientists are very frustrated about the behavior of their Western colleagues who argue so morally. How can it be that such a double standard is applied and accepted? Double standard that is, of course, not only limited to science. Israel is waging a terrible war against people of Gaza and also the West Bank. And this war has just restarted with even stronger destruction and killing of civilian people. Institutes from Israel and are also participating in experiments at DESY and CERN. Israel is also a member country at CERN. Just to be clear, no one questions the cooperation in science with Israel. And I think this is also good so. We have to keep talking to each other, even if sometimes it's difficult. The exclusion of scientists is not a solution. It only promotes isolation, which can be very dangerous because the other side becomes invisible and is excluded. But these double standards and exclusion of at DESY and CERN will most likely have very big consequences. Which country will want to participate financially in future projects if there is a risk of being excluded? Yes, we were probably too naive. Many scientists never thought that politics could rule scientific institutions with long traditions in international collaborations, and where bridges and trust has been built for several decades, and where the Science for Peace idea could be filled with content, especially when it's needed. Our institutions should have said publicly, sanctions in science, not with us. In a very good article in the CERN Korea with the title Science for Peace More Than Ever, the former director of CERN and DESY, Prof, already emphasized in 2022 that bridges should not be cut because there will be an after, and we have to talk to each other again. In the many years, even during the Cold War and later, Science for Peace was a beautiful phrase that was used again and again in public talks, but it's a shame that now, especially at a time when Science for Peace should have played a role, nothing or too little was done by most of the science politicians. But the most important pushback of the Science for Peace idea at DESY was given by the DESY Directorate when they announced in summer 2024, last year, to start a discussion to allow military research at DESY. One has to remember the constitution of DESY does not contain any formulation about work with military, in contrast to CERN. Only in 2013, a so-called mission statement was formulated, which says our research pursues goals that are peaceful and serve civil society. I actually participated in this formulation when I was elected member of the scientific committee at DESY. A signature campaign was launched by the scientists and other employees at DESY to oppose the opening to military research, and above all to say clearly, this is not in our name. This campaign is supported by quite many scientists and employees at DESY, and meanwhile has also quite a lot of supporters worldwide on change.org. The signature list is now open for everybody. The debate on civil class in Germany, and especially at the research institute such as DESY, is very dangerous, since the discussion at DESY could signal a change in global science policy. And this discussion also receives now even further attention with the recent requests to increase the spending for the military. The debate at DESY has given quite some insights. The leader of a beamline, a Petra 3, the synchrotron radiation source at DESY, said in a public event end of last year, when he was asked whether there were cases where this light build was, where this mission statement was important. There he explained that they had rejected a project which was aiming to study explosive materials, as well as another project to study materials under heavy neutron exposure, material which is only used for building nuclear weapons. So these projects could be rejected because there was this mission statement with the requirement and the focus on research on civil and peaceful goals. I think these were wonderful examples why this civil clause is important and is very essential. And already last year, there were visits from representatives from the Defense Ministry at DESY to get informed about possibilities of research at the synchrotron light sources. And there were reports at newspapers and in Germany and also in Nature on this topic. But this is not all. With the sanctions against Russian and Belarusian scientists at CERN and German universities and research institutions, I think a very big step was taken to bring science under the guidance of politics. There are not only the sanctions against Russian scientists and corporations, it goes much further. The focus of politics is becoming clearer now. End of 2024, end of last year, the German research community and Leopoldina presented a report on freedom of science and security interests in time of geopolitical polarization. And there they state, science and innovation are therefore also increasingly being identified as a geopolitical means of power in the sense of national security interests. There is the demand that the intensification of research cooperation with partner states which share the same values is increased, while relations with states that pursue completely different values and goals than Germany and Europe must continue to be subjected to consistent de-risking. But science is universal. It does not depend on whether we have the same values. Exchange, and especially in science, must be kept open with people and countries, even if they see things different. If we understand science as something universal, if we value international cooperations and collaborations, and if we take the Science for Peace idea seriously, then we must try to build and expand international cooperations with all countries, and we must help that science is promoted and that young people have a chance to study. At the Science for Peace Forum, we have just launched a donation campaign to support physics students in the West Bank to continue their study at the University of Naples. We are discussing organizing online courses for students in Gaza and West Bank, if possible, and of course other countries suffering from war. This funding campaign collected more than 5,000 euros in a very short time, and we were able to support 11 students in Naples to pay the university fee for one semester. I must say I was really impressed that so many people of the science community supported this idea and made all this possible. And we must build alternatives for real international cooperation and against national separation. And we have another initiative of the Science for Peace Forum. We will start a workshop in particle physics, a workshop which is based on only remote access and allows everybody to participate, independent of nation, color, gender, and so on. This initiative was necessary since most of the present workshops and conferences are still following the political directives and exclude for the time being Russian and Belarusian scientists. And maybe in future there will be others on the list. The Science for Peace Forum has taken also position in the debate on further increased military spendings. A week ago, we have launched a press statement, no new era of rearmament. We need investments for climate, peace, and the future, where it is said that we need a vision for Europe as being a leading role in diplomacy. And there we need again the Science for Peace idea. And I'm back where I started. Science is needed for building bridges and to keep communication channels open. The attack on science, as is being currently made, I believe is unique in recent history. I think it's important that at DESY and CERN and at many other places, the Science for Peace idea is kept alive and that it's filled with content and applied especially in difficult times. I find it rather impressive that there have been and still are very many positive examples where cooperation and collaboration are kept alive. And it's very encouraging. While this is not encouraged by the directorates, this cooperation is performed and done by the employees and scientists and working together with their colleagues. Thank you very much. We immediately switch
to go forward. Okay, the questions, and then we have the questions on the echo. You keep in mind with the questions you have.
Okay, well, first of all, I'd like to thank Andres and Andrea for the invitation to this colloquium. I think it's a very important initiative, and I wish that more universities, more institutes took as deep an interest in science for peace as you guys do. So my talk will be sort of largely centered on CERN, because as has already been mentioned in the introduction, I spent most of my working career at CERN. And in fact, for many years, I was a sort of roving ambassador for CERN, whose task it was to sort of promote international collaboration. And I may mention a few of those examples in the course of my talk. So during most of this time, I felt that scientific diplomacy was on a rising curve. Unfortunately, as we all know, events, in particular since 2022, have gone in the opposite direction. And at the end, I'd like to discuss those negative trends and promote a discussion with you about what steps we can take to counteract it. So Hannes has already introduced you the CERN Convention. So as he remarked, CERN was founded in 1954, just a few years after the end of the Second World War. And it brought together scientists whose governments had been fighting each other less than a decade previously. And I'd like to pick out three parts of this convention. Research of a pure scientific and fundamental character. No concern with work for military requirements, and its results should be published or otherwise made generally available. I think these are extremely important principles, and it's great that they're embedded in the CERN Convention. It would be nice if they were embedded in the corresponding mission statements of other institutes. So what I'm going to do now is just go through some of the development of CERN's internationalization. So as Hannes has already commented, its foundation was actually under the auspices of UNESCO. And the United States actually played an important role as a sort of midwife to the foundation of CERN. In particular, Rabi, whom you see here in the top left, was very influential in promoting the idea of a European Institute for Physics Research. And as you saw from the convention, I think it was absolutely explicit from the beginning that Science for Peace was one of the objectives. So it was actually very shortly after the foundation of CERN that it had relations with Russia and with institutes in Russia. So first contacts with the Joint Institute for Nuclear Research in Dubna were in 1958, 1959. 1967, there was an agreement with Serpukhov in the Soviet Union. And in the middle bottom picture, you see a bottle of vodka that was presented when the proton synchrotron at CERN started operations. And bottom right, you see a transport plane which was taking equipment from CERN to participate in a Soviet experiment at CERN. I also showed a few different versions of this map of Europe, which shows member states at the time. And what you see here in dark blue initially, most of the member states were in the western part of Europe. Interestingly, not all of them. Yugoslavia was a founding member of CERN, but then it withdrew, and long and complicated story. But there were no member states in Central or Eastern Europe, and there were no member states outside Europe. So I already mentioned some of the engagements between CERN and the Soviet Union on individual experiments. Partnerships, participations by non-member states of CERN in CERN experiments grew during the 1970s. It was the beginning of the 1970s, the first proton-proton collider, the intersecting storage rings, ISR, was constructed. And there were, for example, physicists from the US who were involved in the first experiments. Later that decade, the super proton cyclotron at CERN started operations. And there was participation in many of the big experiments there by China, by Dubna, by the Soviet Union, neutrino experiments and muon experiments. The 1980s saw the advent of the anti-proton collider at CERN, which discovered the W and Z bosons in 1983. And I just mentioned here that the US played a particularly important role in the collaborations that discovered those particles. The people that you can see here are Carlo Rubbia on the left, Simon van der Meer on the right, who shared the Nobel Prize for the W and Z discovery. On the left, you see the magnet of the UA1 experiment. Does anybody know where that magnet is now? The answer is it's in Japan. It is now part of the near detector at Japanese neutrino experiment. The real big expansion to include in CERN experiments many non-member states came in the 1980s and 1990s with the experiments at the Large Electron Positron Collider, LEP, that started operation in 1989. And I don't pretend that I've listed here all the countries that participated, but there's some interesting ones. So, China, US, Canada, Israel, Japan, Korea, hundreds of physicists from around the world participated in those LEP experiments. And I think this is the first giant step of CERN towards globalization. So during this period, the 1980s and 1990s, the geographical spread of CERN in terms of its member states extended towards the east. So around the time of the fall of the Berlin Wall and the collapse of the Soviet Union, Czech and Slovak republics, Hungary and Poland joined, Finland finally felt that it had the freedom to join and did. You also see Bulgaria became a member state. And more recently, Romania, Serbia, Israel, and Estonia have joined CERN. So Israel is the first non-European country to become a member of CERN. And that came about as a result of a policy change by the CERN Council around 2009. So CERN reviewed its policy on who could become a member state. And it said for the first time that non-European countries could become members. Previously, there's no restriction. CERN was founded with the intention of helping European countries, but it never said non-European countries are not welcome. So Israel became a member. Another innovation by the CERN Council, which I would like to mention, is in addition to the status of membership, CERN also opened up international agreements, short of membership, with non-member states to cover participation, for example, in experiments or R&D projects. And there's now something like 50 countries around the world which have these international cooperation agreements. So the true globalization of CERN, of course, culminated with the LHC. So during the 1990s, this process was already getting underway. It was given stimulus by the collapse of the SSC project in the United States in 1993, following which the US, Soviet Union, and Japan promised to make substantial contributions to the LHC accelerator as well as the experiments. And they were admitted as observers at the CERN Council when LHC matters were being discussed. So in the bottom left here is an amusing picture. It shows you then Director General of CERN and a director from Novosibirsk in the Soviet Union sitting on a stack of magnets provided by the Soviet Union for the transfer lines for protons into the LHC. So there was a period of several years in the 1990s where trucks would come from Novosibirsk in central Siberia to CERN and deposit magnets. These were trucks that carried goods from Europe to the Soviet Union, but these were the first substantial pieces of equipment to come the whole way. So in addition to those countries that contributed to the LHC accelerator, there were dozens of countries that contributed to the experiments. And I don't promise that I've got a complete list of them here, but you might find it amusing to look through my slides afterwards and spot your favorite country to see whether it's in there somewhere. Argentina is in there. Bottom left, just saying. And for those who take an interest in these things, Ukraine is there bottom right and top right. So Ellis has already shown you this picture, which I think is very symbolic and very impressive. I think there were a couple of details that you didn't specifically mention. Maybe I wasn't listening properly. That these pieces of brass were shipped to Belarus to be melted down to become a component of the CMS calorimeter, and the whole project was largely paid by the US. So during this period, the number of CERN users went up by leaps and bounds. Until now, there's something like 12,000 scientists who use the CERN facilities, coming from something like 100 countries. And this runs from 1970 to 2014. I'm sure there's a more up-to-date one. It would be nice to see one which goes back further in time. I mentioned that because my first stay in CERN was a summer student in 1968, which is not on this graph. And for me, that was a very formative experience because, like Hannes, it was my first exposure to scientists who came from very different countries whose governments looked at things in a very different way from the way that my government. So this is a recent compilation of how many scientists come to work at CERN from which countries. So there's member states in the top left, associate members lower on the left, observers. So I remind you that Japan, the US, and Russia became observers at the CERN Council following their contributions to the LHC accelerator. But now Russia is in parentheses because it's the agreement with Russia has been terminated by the CERN Council. So in 2009, CERN Council agreed on a globalization strategy, which was to open membership of CERN to countries anywhere in the world. And I already mentioned that Israel took advantage of that possibility. Create the status of associate membership, again, open to all states. And there's some interesting ones here. There's Brazil, first country in Latin America, Pakistan and India. And one of the little ideas that I had when I was negotiating with Pakistan together with the CERN DG was that if we could persuade Pakistan to become an associate member, then surely India would follow, which it did. Another idea which we had was that if we could persuade Ukraine to become an associate member, then Russia would follow. They did. At one time, they expressed some interest, but it never happened. Okay, so CERN has agreements with many international organizations. Joint Institute for Nuclear Research in Dubna. European Southern Observatory was actually hosted by CERN for a decade in the 1970s. An agreement was made with the what was then the European Commission in the 1980s. One comment that perhaps people may not realize, CERN was founded before the European Union, before the European Commission. It was one of the very first European organizations. The only one that came previously, I think, was the Iron and Coal Community. I forget the precise name. That was just slightly early. And CERN has also served in some form or another as a model for other international scientific organizations. Sesame, for example, which is an accelerator, synchrotron accelerator laboratory in Jordan, which counts among its member states Israel, Palestine, Iran, Pakistan. I would love to be a fly on the wall during their council discussions. It has an observer status with the United Nations, agreement with many other international organizations such as the European Space Agency. So Dubna, almost since the beginning, has been a partner organization of CERN. And Dubna, in particular, has always emphasized this Science for Peace motivation for the two laboratories. And this picture is taken from an exhibition put up by Dubna in the United Nations building in Geneva. So the person speaking there is Sasakian, who was, I think at that time, deputy director of Dubna. Director Kadashevsky is on the left there. Okay, so I was actually asked to give the first version of this talk in 2014. Council asked me to give a talk about CERN's international relations, and it kind of stopped with this slide here, talking about challenges for the next large CERN accelerator, which might be future circular collider, which in its E plus E minus and hadron-hadron phases would be at the forefront of accelerated physics for the next 70 years. It's clear that such a project would have to be, in my mind, truly global. And so I listed here some of the big international partners that one would like to have: US, Japan, Russia, and China. That vision for the future between CERN's 60th anniversary and its 70th anniversary looks rather far out of reach. So, as we all know, Russia invaded Ukraine in 2022. CERN responded in 2023 after very tough discussions in the CERN Council by suspending its international cooperation agreements with Russia, Belarus, and Dubna. Also in 23, Hamas attacked Israel from Gaza. Israel invaded Gaza. Finally, 2024, CERN terminated the international cooperation agreements with Russia and Belarus, with the consequence that all Russian physicists affiliated with Russian institutes would have to leave CERN, and that they maintain their authorship rights for 1 year, but then out. The one sort of small piece of light in all this sad story is that in 2024, CERN Council decided to maintain the agreement with Dubna. So it's frozen. The collaboration can't be expanded, but at least it is maintained. So just in the last week or two, I've added another development, not necessarily positive, as the Japanese emperor said in 1945, namely a new American administration. So currently the status of Russian scientists at CERN is they can't come to CERN. They can sign papers with the remark that the authors are affiliated with an international laboratory or with an institute formally covered by a cooperation agreement with CERN. As I already mentioned, their authorship rights will expire after a year, even though in many cases they've been working on the CERN experiments for 20 years or more, which I leave it to you to decide whether that's fair or not. So, of course, CERN is not the only international institute that's had to struggle with what to do with its Russian collaborators. So there's the XFEL at DESY, free electron laser. Russia is still a member, but it cannot send scientists to work at XFEL. And the same thing is true of the FAIR nuclear project, so GSI. Somewhat bizarrely, the international collaboration which seems to be least affected is the International Space Station, where there's still Russians and Americans on the same International Space Station. Western astronauts go up on Russian rockets, etc., etc. And ITER still has Russia as a member. So I feel that CERN is a little bit out on the limb here, also DESY, as we discussed. However, there are other institutes which have been extremely strict. Scientific collaboration with people at the Max Planck Society in Germany has been stopped. And I know of at least one UK university where all the faculty members would have said, no collaboration with Russia, China, or Iranian physicists, not even informal collaborations, just no contact, no scientific contact whatsoever. I don't know how widespread this is, but this is the most extreme example. So one of the things that we've been grappling with in the Science4Peace Forum was how to mitigate the effects of scientific sanctions on scientists from Russia and Belarus, particularly effects on students, providing them with access to workshops in schools. This is already mentioned, an initiative that the forum is taking in regard. I would hope that the fact that there is still collaboration with Dubna may serve as a possible channel for contact, maintaining contact with the Russian scientific community, and thereby keeping some little crack in the door open for contact between the West and Russia. I also think that we have to think carefully how to prepare for post-war collaboration. This is one of the points that Herwig Schoppler made in his essay that Hannes mentioned. And maybe this is becoming a bit more topical because there may be some progress being made towards a ceasefire in Ukraine. And if that were to happen, then would that affect the climate for possibly renewing some sort of contact between Russian and Western scientists? I don't know. So before ending, I would just like to touch on a couple of other topics. So one of the things that I've been particularly interested in at CERN is schools for PhD students. And in fact, since 1962, CERN has had a collaboration with Dubna organizing schools. Interestingly, that collaboration with Dubna persisted all during the Cold War, and even when there was the invasion of Czechoslovakia in 1968, there was a small hiccup, then it continued. And CERN is also involved in organizing schools in Latin America and Asia, and welcomes something like 300 international students. So among those students are students from Palestine. While I was looking after CERN's external relations, I got an application from a Palestinian student to come to CERN for the summer. But I didn't have any budget left. So I went to an Israeli colleague and said, do you have some money? And he said, sure, of course I have money. So he provided money for the Palestinian student to come to CERN. And that Palestinian student, together with the Israeli students who were there for the same summer, jointly organized a party, which was certainly one of the big social events of that year. Our times have changed. Anyway, one of the Palestinian students who had been to CERN during the summer went back to An-Najah University in Nablus and has set up a research group. He is a member of Atlas, as he mentioned in passing. CERN has sent computers, and he has a high-performance computing center in Nablus. And the picture on the right here shows a number of the students who are involved in Atlas or been to CERN. So one of my personal interests is promoting scientific collaboration around the Mediterranean. And this I do through a foundation called the Sharing Knowledge Foundation, or SKF. It's only a small foundation, and if you want to donate, you're welcome. We've been providing scholarships to students from Jordan, Morocco, Palestine, both the West Bank and Gaza, and also financing the transfer of computers from CERN to Lebanon, where they set up a high-performance computing center. Okay, so finally, I come to the elephant in the room, by which I mean the United States and what is happening there to science and to scientific collaboration with the United States. So the US is apparently conducting a review of its support to all international organizations. On the first day of the new administration, it withdrew from the WHO. Its membership of UNESCO is under review. The US administration has sent reviews to many UN organizations, asking them questions, like, for example, do you have any funding from China, Iran, Russia? Are your objectives aligned with our US objectives? Of course, as you know, US aid has been dismantled. So what does all this mean for the global efforts to combat or mitigate climate change? I don't know. Will the US now withdraw from the World Meteorological Organization, for example? I just read an article today saying that Elon Musk thinks that the US should withdraw from the International Space Station in 2027. And I've got this little box down here in the bottom right-hand corner, phones. So there was an article in the newspaper today about how a French scientist on his way to a conference on astrophysics was stopped at the US border. The immigration officer looked at his telephone, found that he made some derogatory remarks about the president of the US, and deported him. So if you're thinking of going to the US, just be careful what you have on your phones. I wish it was funny. So what strikes me about this is that for a future big project at CERN, as I already mentioned, I think collaboration with the US would be crucial. And a few months ago, the previous administration signed an agreement with CERN saying it would be happy to participate in the FCC if that goes ahead. Whether the present administration feels the same way, we'll discover. So that brings me to the end of what I wanted to say. Which way forward for relations with Russia? I said very little about the relationship with China, but that's the feeling that China is becoming autarkic in its scientific ventures and is not so interested in collaboration with the West. Are we interested in collaborating with them? What is going to happen to the future of collaboration with the US? What can we do to try to promote some sort of peace in the Middle East? So we have relations with Palestine, with Israel, with Iran and South Africa. Is there something concrete that we can do? So all these issues raise the question of what is the future of international collaboration and how can science continue to promote peace? So don't have the answers. Maybe you have the answers. I only have the questions. Thank you.